Welcome to the YouTube channel Professor Wilcox, where today we do section 2.4 for Algebra 1, Parallel and Perpendicular Lines. I'm going to begin by giving you a couple of questions and concepts from the Chapter 2 Guided Notes and Practice. If you have this booklet, go ahead and follow along with me. I am going to be starting on page 25, which is the beginning of section 2.4, Parallel and Perpendicular Lines. There are two learning targets for today that I can write equations of parallel and perpendicular lines. Pretty simple. Let's start with the parallel. The first thing that we notice is that the slopes of parallel lines have the same slope listed here in the words. Look at the graph of this. If I look at the slope is up 1, right 2, this is up 1, right 2. Notice these lines are parallel. They will never intersect. They are going in the same direction. And I want you to think about two lines that are going in the same direction will always have the same steepness. And you can see from this picture here. So look at this example, y equals 1/2 x plus 1, which is in slope-intercept form. And this y equals 1/2 x minus 2, which is also in slope-intercept form. Both have an m of 1/2. And since these m's are equal, we know that the two lines are parallel. And if the two lines are parallel, then the slopes will be equal. So what we have to do in the first few examples is write the equation of the line that passes through the given point and is parallel to the given line. We are going to use point-slope form, which we've used many times before. Y minus y1 equals m times x minus x1. They already give us a point, 4, -2, which I always want to label this as x1, y1. And we now need to find the slope that we need. It says write the equation of the line that is parallel to it. Well, this line is y equals 1/2 x plus 5. This is in y equals mx plus b form. And my m of this line is 1/2, which means the parallel line is going to be equal to 1/2. Now I can take these three values and plug them into the equation. Y minus my y1 value is -2 equals m. M is 1/2 times x minus, and my x1 value is 4. Now let's assume that when they say write the equation of the line, they want us to put this line in slope-intercept form. So we want to go from point-slope form into slope-intercept form, which is y equals mx plus b. Forgot the m, just squeeze that in there a little bit. So how do we get point-slope form into slope-intercept form? I'm first going to change this to a plus, and then we're going to distribute to get rid of the parentheses. Let's take the 1/2, multiply that by x. 1/2 x minus 1/2 times 4 is 2. And so the last thing that we have to do to get y by itself is subtract 2 from both sides like this. And so y equals mx plus b is going to be y equals 1/2 x plus 4. So the basic idea is the same, that we still use point-slope form, and I'm going to go ahead and use point-slope form with the point that's given and the slope of the line that they gave us. They gave us an example 2, 3, 7, let's call this x1, y1. My equation is y equals 10 minus 2x. If I were to rewrite this as -2x plus 10, wouldn't you agree that in y equals mx plus b form, my slope is going to be -2? Right? So let's take this point, 3, 7, and this slope, -2, and plug it into point-slope form, which we have up here circled. Y minus y1 is going to be y minus 7 equals m is -2, times x minus x1, and x1 is 3, so we'll write this as x minus 3. So I'm going to bring down the y minus 7, and I'm going to distribute -2 times x, and -2 times -3 is a positive 6. To get this in a slope-intercept form, we get y by itself. We're going to add 7 to both sides like this. And my final answer is going to be y equals -2x plus 13. Remember, you want to get your answer into y equals mx plus b form. Let's turn to page 26, and we'll get a couple of examples going here. There will be some cases where I have to rewrite the equation to find out what the slope is. All right, they gave us, let me use a different color. All right, they gave us -1, 6, so we'll call this x1, y1. Got to figure out what is the slope of this line. That's what we care about. The slope of this line. Now, I don't have y equals mx plus b. That's the best way to figure out what the slope is of this line. So let's get y by itself. I notice that it's a minus y, and here's the little trick that you can do. Can I just bring the y over here to the right? And that would make it positive. And so now instead of 9 plus y, I'm going to write y plus 9, just to get y by itself over here, and that's equal to 3x. And now I can just minus 9, and I have my equation, y equals 3x minus 9, that I can now use to get the slope. Well, you can just look at this equation and tell what the slope is, which is going to be the m value, or the number in front of the x. So let's use the point and the slope, and we're going to plug these into point-slope form like we did before. Here's x1, y1. So we'll write this, I'll put my m equals 3 here. Y minus y1, which is y minus 6, equals m, which is 3, times x minus x1, which is going to be x minus minus 1. Be careful that you change this to plus plus, right? In order for us to get this into y equals mx plus b, let's distribute and get rid of the parentheses. So my parentheses have a 3 in the front, 3 times x, which is 3x, and 3 times 1, which is plus 3. The last thing that I do here is add 6 to both sides like this, and 3 plus 6 is 9. So my final answer is y equals 3x plus 9. On number 4, I'd like you to try this one on your own. Pause the video, try number 4 on your own, and see if you can get the answer correct. So I want to take my 9, 11 and label this as x1, y1. I need to figure out what is the slope of this line so that I can use the slope for my equation, because parallel lines have the same slope, and I want to be able to calculate what that slope is. Let's put it in y equals mx plus b form first and see if we can figure out the m. I'm going to subtract 2x from both sides like this, and I'm going to write this as 3y equals, I'm going to put my negative 2x first, and then the plus 16 is going to come down like this. To get y by itself, let's divide everything by 3. And you can really stop here. I'm just rewriting this so that I can figure out what the slope is of the line. And it looks to me like the slope of the line is the number in front of the x or the m. So in this case, the slope is equal to negative 2/3. That's the slope that I want to use for my equation. So let's use negative 2/3 as my slope and my point 9, 11. So y minus y1 is going to be y minus 11 equals, my slope is negative 2/3 times x minus, my x1 value is 9. So we'll put that right here. To get y equals mx plus b, let's first distribute. I'm going to take the negative 2/3 x and bring that here. And negative 2/3 times negative 9 is a positive. And how do we do this? I can do 2 times 9 is 18. Think of this over 1. And 18 divided by 3 is 6. So y minus 11 equals negative 2/3 x plus 6. Let's add 11 to both sides like this, and y equals negative 2/3 x plus 17. That's in slope-intercept form. And for the second part of today's lesson, let us talk about perpendicular lines for a moment. There is something, sort of a phrase that I want you to remember when it comes to perpendicular lines. As parallel lines have the same slope, perpendicular lines have what we call opposite reciprocal slope. And so let's talk about what this means. Opposite means you change the sign, and reciprocal means that you flip it over. We have to do both of these items to get a slope that's perpendicular to it. Notice in the graph of this picture, this is a negative slope, this is a positive slope, and that's why they are opposites, right? Perpendicular meaning that these two lines are going to intersect at a right angle, or 90 degrees, okay? And look at these two slopes that we found. Okay, this positive slope here is a slope of 1/2, up 1, right 2, up 1, right 2. And the slope of the other line has negative 2. So if I start here, down 2, right 1, down 2, right 1. Notice one's positive, one's negative. And notice they are reciprocals. If I take the 1/2 and flip it over, the reciprocal of 1/2 is positive 2. So if we can do both of these items, we can find the slope of the line that is perpendicular to it. Let's move up to the top of page 27 and work on number 5. So write the equation of the line that passes through the given point that is perpendicular. Again, we're going to use the same formula, y minus y1 equals m times x minus x1. And again, they give us a point. Let's call it x1, y1. Now, the slope of the line that we have is 4, because this is y equals mx plus b. But what is the slope of the line that we want? We want to be perpendicular, and perpendicular is opposite reciprocal. So the opposite of 4 is negative 4, and the reciprocal of 4 is 1/4. So the slope of the line that we want is negative 1/4. Whenever we're looking for a perpendicular slope, we have to take the opposite reciprocal to find it. Let's take these three numbers and plug them in the equation like we've done before. Y minus my y1 value is 0 equals m, which is negative 1/4, times x minus 8. I always like to circle the slope that we want. I write down the slope that we have. The slope that we have of the line is 4, but I want the one that's opposite reciprocal to it, so I circle that one so that I don't get confused. Y minus 0 is just y, so we can bring that down. Negative 1/4 times x is negative 1/4 x. And negative 1/4 times 8, well, negative times a positive is a negative. And 1 times 8 is 8 divided by 4 is 2. Let's try that again in number 6. Again, they give us a point. 6, negative 3, we'll call this x1, y1. I have to figure out the slope of the line in number 6. Well, let's get y by itself by subtracting 5x from both sides like this. Because if I get y by itself, then I can find out what the slope is. Negative 10y comes down. I'm going to write my x term first, negative 5x, and then I'm going to bring down the plus 8. Let's divide by negative 10, divide by negative 10, divide by negative 10. Now, this is kind of a strange line, but all that I'm concerned about is the slope in front of the x. And negative 5 over negative 10 is really a half. That's a positive 1/2, and the x comes down. I mean, who cares about this 8/10, which I guess is really negative 4/5? I don't care about that. I'm only worried about what the slope is of the line. Let me draw some lines just to separate my work here. So 1/2 is the slope of the line that we have. What is the slope of the line that we want? Well, opposite reciprocal. The opposite of 1/2 is negative 1/2, and the reciprocal of 1/2 is 2. So the slope of the line that we want is negative 2. So now I can take my slope and my point, and we can plug them into point-slope form, which we've listed at the top of the page here. I'm kind of squeeze this in. Y minus y1 is y minus minus 3 equals m, which is negative 2, open, times x minus 6. All right, let's take the minus minus, change that to a plus plus. So y plus 3 comes down. Let's distribute. Negative 2 times x is negative 2x, and negative 2 times negative 6 is a positive 12. Last step, I subtract 3 from both sides like this, and I say y equals negative 2x plus 9. Final answer in slope-intercept form. But more to do, let's look at number 7 here. They give us another point. This is x1, y1. Let's find the slope of the line. Subtract 2x from both sides like this. I write this as 5y equals negative 2x plus 15, and then divide everything by 5 to figure out what is the slope of the line. Y equals, all right, my slope is negative 2/5 x, and then the plus 3 comes down. So there's my line. The slope of the line that we have is m, which is the number in front of x, which is negative 2/5. Sorry, I wrote negative 2/3. The slope of the line that we want is opposite reciprocal to this. Opposite of negative is positive. Take 2/5 and flip it over. Take 2/5 and flip it over, and that becomes a positive 5/2. This is the slope that we want. So now we're home free if we take the slope and the point and we plug it into point-slope form. Y minus y1 equals m is 5/2. Open, x minus x1 is 10. Let's get it in slope-intercept form by using the distributive property. 5/2 times x, I write as 5/2 x minus, so to multiply this 10 by 5/2, I can do 5 times 2 is 50. 50 divided by 2 is 25. Final step, add 8 to both sides like this. So I'm going to write this as y equals 5 halves x. Negative 25 plus 8, be careful with this, is a negative 17. And there's my final answer. All right, couple more questions here to go. Number 8. They give us a point, 5, negative 4. Let's call this x1, y1. Now this is a very interesting line here. X equals negative 2 does not look like anything else that we've had yet. I want to think about this. X equals negative 2 doesn't even have a y value. It says x equals, and what this means is that it goes through the x-axis at negative 2. And what that means is that it's just a vertical line. And if I think about this, the slope of a vertical line is undefined. And so a perpendicular, if I think about an undefined line, what type of line would be perpendicular to vertical? Well, the answer is horizontal. So I should have a line that looks like this, if it would be a right angle to that. Notice that there are all kinds of horizontal lines that I could write that were perpendicular to this vertical line. So the question is, which one is it? What I do know is that the slopes of all horizontal lines are equal to, wait for it, 0. So now I have the slope of the line that I want, which is perpendicular to this vertical line, and now I can plug it into the form. Y minus y1 equals m, which is 0, times x minus x1, x minus 5. This is the slope that I'm using. Well, let's see here. If I have minus minus, we'll change that to plus plus 4. And 0 times x is 0x, and 0 times 5 is just 0. And so 0 times all this stuff is just 0. So isn't this just equal to 0, right? And then we get y by itself, and I subtract 4 from both sides, and I say y equals negative 4. Remember something with this question. Whenever I have x equals a number, and that's all, it's always a vertical line through the x-axis. When I have y equals a number, and that's all, it's a horizontal line through the y-axis. And so if I think about the graph of this, it goes through the point 1, 2, 3, 4, 5, down 1, 2, 3, 4. It's going to go through that point and be horizontal through the y-axis at negative 4. Negative 1, 2, 3, 4. I want you to pause the video and think about number 9 and try to do that question. And so thinking about number 9, we have a point that's x1, y1. We'll use that. And they gave us y equals 8. Well, we just talked about that a minute ago. If I have a y value of 8, and that's all, there is no slope. I mean, think of this as y equals 0x plus 8. What type of line is this? A line that has a slope of 0 is horizontal, and it's going to be horizontal through 4, 5, 6, 7, 8. So my line is going to look something like this. So now I'm thinking about what type of line is perpendicular to horizontal, and the answer is vertical. And I want to know what line, there's negative 2 and up 7, which takes me here, right? What is the line or the equation of the line that goes through that point, negative 2, 7, and is perpendicular? Well, it has an undefined slope, but I do know that all vertical lines, just like number 8, come in the form x equals a number. And so in this case, is going to be x equals something. And if you look at the point that we're going through is negative 2. So the answer here is going to be x equals negative 2. I hope you got that right. I hope this has been helpful for you. And if you have any other questions, you can contact me on Remind, over email at jwilcox@davisonschools.org, or find me in room 312. Have a great day.